In this lecture, we are going to deal with first part of data transfer instructions in ARM. So first of all, what is the main purpose of data transfer instructions? It is used for loading and store operations. Loading means what? You are going to load content of a memory location to a register. So if you are moving a data from a memory location to a register, it is known as load operation. Similarly, store means what? We are going to store the data present in a register to a data memory location. That is known as store operation. So for load as well as store operation, we are using data transfer instructions. And what are the different types of data transfer instructions available? It can be used for moving word, signed or unsigned half word, signed or unsigned byte, right? So these kinds of operations can be possible. You can either load or store a word of data. What do you mean by word? How many bits? In the case of ARM, word means 32 bits, right? So you can be able to move a word of data, signed or unsigned half word data. Half word means what? 16 bits. Similarly, you are able to load or store signed or unsigned byte of data. So if you are using load operation, you will be moving from memory to a register, right? That is why it is written 2. And if you are using store operation, you will be storing from register to memory. That is why it is written to and from the registers. Next one, it can be used for loading PC also. What is PC? Program counter. Why it can be used for loading PC? Because PC is also one of the register present in the set of registers, that is R15. And this will be used whenever the target address is beyond the address that can be handled by the branch instruction. Branch is a special type of instruction which can be used for branching operation, and there 2 GB address space can only be addressed. That we will see later. So now you understand that this LDR or STR can be used for loading program counter also. So these are the different types of load and store instruction available. LDR means load, STR means store. So LDR stands for load word, STR stands for store word. LDRH stands for load half word, STRH means store half word. LDRSH means load signed half word, STRHS means store signed half word. Similarly, LDRB means load byte, here store byte. LDRSB means load signed byte, STRSB means store signed byte. So these are the different types of loads and store instruction available in ARM. So first we will see with the single register load operation, right? And here it is coming under an addressing mode known as base plus offset addressing mode, and it is also having indexing as pre-indexing, and the offset will be immediate offset. We will see all these words one by one with an example. So first of all, let us take this is the data memory, right? This is your data memory, and these are the address of each locations available in the data memory. So here you can see that the data memory is starting from 4000 onwards. Why the data memory starting from 400 onwards? When we have seen the memory map of LPC2148, we have seen that data memory is starting from 0x4000. That is why we have taken the starting of data memory as 400, right? So in this data memory, in the corresponding location, that is 4000, you are having a data known as 0x10101010. In the next memory location, that is 4004, you are having another word of data, that is 20202020, right? Another next memory location, you are having 003, right? So here you can see that this is the data memory. These are the address location corresponding to each location in the data memory, and these are the data stored in the corresponding memory locations. Similarly, here you can see these are the three registers. In this example, I am using one or two registers. So for time being, I am taking three registers, R0, R1 and R2. And these are the contents, or these are the data available in these registers. By default, all the data will be having 000 as the data. So this is a data memory with the corresponding memory address. This is a register with the corresponding data stored in it. So now let us see one example for load. So I am using an instruction LDR R0 comma equal to 0x4000. What does it mean? This instruction is used for moving a constant data. In our case, this is an address. So you are going to move a constant 32-bit data to R0 using this instruction. So what does it mean? You are going to move this constant data or this immediate data into this R0 register. So now what is the content of R0? 000. After executing this instruction, what will happen? This immediate data will be moved on to R0. So R0 will be having this data, right? So what does it mean? In our case, I told 4000 is nothing but an address location of a data memory. So your R0 is containing the address of data memory. So if a register or a variable is holding the address of memory, what do you call that register or a variable? It is known as a pointer. So R0 is pointing to an address location known as 4000, right? So LDR R0 comma 400 means this immediate data you are moving to R0, and since it is an address location, R0 is acting as a pointer because it holds an address location. So now R0 is pointing to this address location. Next we will see the next instruction LDR R1 comma bracket R0. So what does this bracket shows? Bracket shows that you are going to move the data pointed by R0 to R1. You are going to load the data pointed by R0 to R1. What is the data pointed by R0? R0 is nothing but a register, and what is the content of that register? An address, right? So R0 is a pointer to this address. So what will be the data pointed by this R0? That is the data present in this address, right? Bracket R0 means you are going to move the data pointed by R0. So in this case, the data pointed by R0 is nothing but the data present in this address. What is the data? 1010101010. So what does this statement, what does it do? It will be moving the data pointed by R0 to R1. So this data will be moved to R1. Now what is the content of R1? 000. After executing this, what will happen? The content of R1 will be this data, right? Then we will see the next instruction. So I am writing LDR R2 comma R0 comma hash 4. Here what does it mean? What is the difference between this and this? You are adding comma hash 4 here, right? So here what does it mean? R0 is known as a register which is holding an address. In our case, it is also known as base address, or it is a starting address. To that base address, you are going to add an immediate data or an offset data, immediate offset known as 4. So in this case, what you are doing? You will be adding 4 to this base address. What is the base address? 4000. To that you are going to add 4. So what will happen? What will happen? Your pointer will be incremented to 4004. Right. Bracket R0 means you are going to load the content of data pointed by R0. Similarly, here in bracket one more value is there, that is #4. What does it mean? The address present in R0 will be incremented by 4. So what does it mean? Content of R0 or address present in R0 will be incremented by 4. That means you are incrementing the pointer R0 to 4004. And since you are having this bracket, what does it mean? The content of this updated address. What is my updated address? 4004. How I got this? You are adding the base address present in R0 with 4. Right? So my updated pointer address is 4004. Right? And since bracket is there, whatever data is present in this updated address will be moved on to R2. Whatever data is present in the updated address, that will be moved on to R2. So initially R2 will be having 000. After executing this, what will be the content of R2? 20202020. What do you mean by LDR R1 comma bracket R0? The data pointed by R0 will be moved on to R1. Then LDR R2 comma bracket R0 comma #4, what does it mean? The address stored in R0 will be incremented by 4 and the content of that updated address, that is 4004, will be moved on to R2. Right? So after moving this, what will be the updated address? 4004. But you should keep in mind that once the updation is done, the pointer will go back to 400 itself. Pointer will go back to 400 itself. That means the address present in R0 remains unchanged. Even though the updation was taken place, content present or the data or the address present in R0 remains unchanged. You should keep in mind this, right? So this instruction is coming under base plus offset pre-indexed addressing mode with immediate offset. Why it is known as base plus offset addressing mode? Because you are having a base address stored in R0. In addition to that, you are having an offset address, right? That is 4. And what type of offset address you are having? It is an immediate offset address. That means immediate data. That is why it is known as with immediate offset. So R0 is the base address. To that you are adding the offset of type immediate. Then why it is known as pre-indexed addressing mode? Pre-indexed means you are adding the base and offset, or you are performing the incrementing operation before load operation is done. Right? You are updating or you are incrementing the address before performing the load. So you will update the address, then from the updated address only you are loading the data. Right? That means the indexing will be done before load operation. That is why it is known as pre-indexing or pre-indexed addressing mode. That means the indexing will be done or the incrementing will be done before performing load. Then we will see the next example. So here again we are seeing the single register load, but here you are having one difference. You are adding one more term known as write back. In the previous case we have seen that even though the indexing was done, the register value, that is the address present in R0, remains the same. It was not updated. But here you can see that register will get updated. You can see by the help of an example. So similarly we are seeing the data memory and the content of registers, what we have seen before. You are writing the first instruction LDR R0 comma equal to 4000. What does it mean? This constant address you are moving to R0. So R0 is having that address. So R0 is acting as a pointer which is pointing to this address. Then the next instruction LDR R1 comma bracket R0. That means content of the pointer that is R0. Content of the pointer pointed by R0, that is this data will be moved on to R1. This data will be moved on to R1. So you can see that R1 is having this data. So in the next instruction, what you are seeing, LDR R2 comma R0 comma hash 4. What does it mean? The address stored in R0 will be incremented by 4, right? And the data present in that updated address will be moved on to R2, right? But here one difference is there. You can see one exclamation mark here. So this is used for write back operation. What do you mean this? What do you mean by this write back? Once the indexing has taken place, or once you have added 4 with the base address stored in R0, that is 4000, will be added with 4. So what will happen? R0 will increment to 4004, but one more operation will take place. What will happen? You can see that content of R0 will be updated with the new address. That is known as a write back. In the previous case, even though the updation of pointer was taken place, but R0 was not written back with the updated address. So whenever you are using this exclamation mark, the updated address or indexed address or incremented address will be updated in R0. That is very important. So this exclamation stands for this write back operation. Then what will happen? The operation will be saying whatever data is present in the updated address. What is the data? This data 202020. So this data will be moved on to R2. So the operation of this instruction and the previous instruction without this exclamation was the same. Both are the same, performing same operation, but only difference is that the address will be updated in R0, or the R0 will be written back with the new address. That is meant by this exclamation mark, right? That is known as a write back operation. So you can see that R0 address is updated, and what is this known as? This is coming under already base plus offset addressing is there. That is why I am not writing it here, because whenever base address and offset is there, it is coming under base plus offset addressing. And what type of indexing it is having? Again, it is pre-indexing, because the incrementing or indexing was done before performing load. So it is pre-indexing. And what type of immediate value you are having? What type of offset value you are having? Immediate offset value, right? Immediate offset value you are having. And one more thing is that write back operation was also done. Write back is also known as auto indexing. So this addressing mode is coming under base plus offset pre-indexed addressing mode with the immediate offset and write back. So here this write back is very important since you are adding this exclamation mark. And in the next example we will see the same single register load operation, but till now we are dealing with pre-index addressing mode. Now we are going to deal with the post-index addressing mode. So these two instructions we have already seen. The next instruction you are writing LDR R2 comma bracket R0. So in bracket you are having only R0. Outside the bracket you are writing comma hash 4. So what does this instruction means? Whatever is present inside the bracket, right? What does it mean? If we are putting a bracket around R0, what does it mean? The data present in R0 will be moved on to R2, right? So what is the data present, or what is the data pointed by R0? 100. So this data will be moved on to where? R2. What is the data present? What is the data pointed by R0? Data pointed by R0 is this. That data will be moved on to R2. So what will be the content of R2? Previously R2 was 00. After executing this, the data pointed by R0, that is this data, will be moved on to R2. So both R1 and R2 will be having the same data. So after the load operation is completed, then incrementing will take place. Right? That is why it is known as post-indexing. First, load will take place. From where to where it is loading? The data pointed by R0 will be loaded to R2. So data pointed by R0 was this one in the previous case. That will be loaded to R2. After loading operation is completed, the pointer will increment. Content of R0 will increment. That means R0 will point to the 4004. And what will happen to the R2? What will happen to R0? It will be updated with the 4004. Right? So now you can see that R0 was updated with the 4004 in the case of post-index addressing. But you need to keep in mind that the exclamation was not there in the case of post-index addressing mode. Right? So in post-index addressing mode, even though you are not using that exclamation mark, the resultant address or the address of the address stored in R0, that is the base address, will be updated with the indexed address. Right? You have incremented the address present in R0 by 4. So previously the address was 4000, that you have incremented with 4. So your resultant address will be 4004 and this address will be updated in R0. So after executing this post-indexed instruction, the address stored in R0 will be updated with the new address, even though you are not putting the exclamation mark. Right? So it is known as post-indexed base plus offset addressing mode, and the type of offset value was immediate offset. So previously it was pre-indexed addressing mode, now it is post-index addressing mode. That means the load operation will be done, right? The value pointed by R0 will be loaded to R2, then R0 address will be incremented by 4. That is known as post-indexing. Right? Operation will be done, then only indexing will be done. Now we will see the store operation. So till this instruction we have seen in the previous example. So what will be the updated address in R0? 4004. Right? So next we are going to see an instruction str r2 comma bracket r0 comma hash 4. What does it mean? R0 comma hash 4, what does it mean? You are going to increment the address present in R0. What is the address present in R0? 4004. You are going to increment this address by 4. That is meant by this bracket R0 comma hash 4. And you are going to write back. That is meant by the exclamation. So after executing this part alone, what will be the updated address in R0? 4008. So now you are going to add 4 to this 4004. So what does it mean? You are going to increment the pointer from 4004 to 4008 and this updated address will be stored back to R0. So you can see that R0 was updated to 4008, right? So now R0 is pointing to this address. Then we will go on to the operation. What is my operation? Store operation. What does this store operation do? It will store the content of this register. Content of which register? R2. The content of this register will be stored onto this resultant memory address. Or this content of R2 will be stored onto address pointed by R0. Now what is the content of R2? 101010. This data present in R2 will be stored onto address pointed by R0. What is the address pointed by R0 now? 4008. How you got this 4008? You will be adding 4004. That was the address present in R0 previously, 4004. To that 4004, you are adding 4. Right? So now you are updating R0 to 4008. Right? That means your R0 is pointing to 4008 memory location. To this memory location, you are going to store the content of R2, right? So in the case of store, you are moving the data from left to right. In this case, R2 to address pointed by R0, left to right. But in the case of LDR, it was from right to left. So in STR, it is from left to right. So you are going to store the content of R2, that is 101010, to the address pointed by R0. So what will be this data? This data will be overwritten by this. So whatever content is present in R2, that will be stored onto the address location pointed by R0. So what will be the updated value present in 4008? The same value 10101010, right? So this is how store operation is performed. And since again this exclamation was there, your address was updated. If exclamation is not there, address will not be updated, right? So what is this type of addressing known as? Pre-indexed addressing mode with write back. And for the store operation also, you can perform this kind of post-index addressing mode. So for load and store, you can perform pre-indexed addressing mode or post-index addressing mode. Both can be performed irrespective of which instruction you are using. For both load and store, pre-indexing as well as post-indexing can be performed. Only difference is there in the instruction or what operation you are performing.